So in this video, we are going to be studying the distribution of sample proportions. Here's an example. It is believed that 85% of San Francisco voters are Democrat. A researcher surveys a sample of 310 voters and calculates the proportion of Democrats and finds that there to be 82% of Democrat. She repeats the poll again, selecting another 310 voters, and she calculates the sample proportion. This time, the sample is 87% Democrat. She keeps repeating this process multiple times. So, in other words, she's taking samples of size 310 and calculating the sample proportion of Democrats, producing a large number of sample proportions p hat. So just a couple things before we move on. The first question is, what is the population we are studying? So what is the population here? So the population is San Francisco voters. Okay, so that is our population. If you said 310 voters, that would be our sample. My second question, just to get kind of warm us up, is 85% here that you see, is that a parameter or is that a statistic? Okay, that is actually a parameter because it's a number that describes a population. And the correct notation we're going to use for that is just a p. P is equal to 0.85 or 85%. Okay. The other question I have for you is 82% a statistic or a parameter? Okay, and that one is a statistic because it's calculated from a sample. And the correct notation there is p hat. Similarly, this guy is a statistic. We have p hat equals 0.87, and she keeps computing more and more of the p hat. So there's going to be lots of p hats here. Okay, and since it's going to come up on the homework, I just wanted to mention a quick way to remember that is for populations, we have populations correspond to parameters. So parameters describe population, and samples correspond to statistics. So the easy way to remember that is PP and SS. Okay, but let's move on. So if you recall, it is believed 85% of San Francisco voters are Democrat, so that's our population data. And the researcher keeps taking these samples of size 310 repeatedly and calculating the sample proportion of Democrats. So the first question we have is, what is meant by the sampling distribution of sample proportions? So this is also known as the sampling distribution of p hat in this particular case. And it is simply, it is the distribution of the values of all samples, sample proportions, p hat, if we take repeated samples of the same size n equal 310. So in other words, if this researcher could just keep taking sample after sample after sample and calculating the sample proportion, it would be the distribution of all those samples. Now, the idea here behind the sampling distribution is that, we know something about the population. So the question is, what can we say about the samples? Like, what can we expect of the samples? So if we know that 85% of San Francisco voters are Democrat, well, what do we expect samples to look? The samples of size 310, what do we expect the sample proportions to look like? So here's our second question. In this example, Is a normal model a good fit for the sampling distribution of sample proportions? So in other words, are the sample proportions normally distributed? And the quick check for that is we just check, is the sample size times the population proportion greater than 10? And in this case, we have 310 times 85%, and that gives me 263.5. That is definitely larger than 10. And we're also going to check the NQ is greater than 10. Okay, and remember, this tells me that my sample proportions are normally distributed, so yes. The next question I have here is C. What is the mean and the standard deviation of the sampling distribution of p-hat? So what is the mean and standard deviation of for the distribution of sample means or sample proportions? Round your final answer to 2 decimal places. Okay, so the notation we use for the mean is mu of p-hat. That is always going to be equal to your population proportion, which is just 85%. The standard deviation of the sampling distribution of p-hat is given by the square root of pq over n. So in this case, that is 0.85 times 0.15 over 310. Now, I would normally just pop that into my calculator, and we get something that looks like this, and it rounds to 0.02, so that's about 2%. Okay, so if I were to draw a little graph of this, if this was the distribution of sample proportions, the mean would be 0.85, and then my standard deviations would be 2%. So like this would be 0. If I went out 1 standard deviation, here's a little note on rounding. In the homework and on the quizzes and tests, my advice is that you really want to try to avoid rounding at any intermediate step of your calculation. For example, if like there's a 3 over root 5 in your calculation, enter this into your calculator if possible. Don't enter 3 over 2.2 because that's going to cause rounding errors that could make your final answer incorrect. If you must round, try to round to at least 6 decimal places for each rounded value. For example, I would use this instead of this. And, you know, if you're rounding at the last step, it's no big deal. It's just when you're rounding at one of the steps along the way. For part D, since the sampling distribution of p-hat is normal, we established that in part B. In this case, we can apply the standard deviation rule. And just to recall, this was the 95, 68, 99.7. Remember, those were the 3 standard deviations, 2 standard deviations, 1 standard deviation from the mean. So for any randomly selected sample of 310 voters, there is a 95% chance that the sample proportion p-hat falls between which 2 values. Round your final answer to 2 decimal places. So if you recall, the standard deviation rule said that approximately 95% of the values lie within 2 standard deviations when we have a normal distribution. So if you recall from the standard deviation rule, we learn that 95% of our values in a normal distribution lie within 2 standard deviations of the mean. So we have to figure out what are these 2 values. So what is 0.85 minus 2 times the standard deviation, and we've got to figure out what is our mean plus 2 times the standard deviation. And I'm going to just fill in the same values as before. Okay, and normally I would just put these in my calculator just like this to avoid, rounding. If you need to round, as I said, just make sure to go out 6 decimal places to be careful. So in this case, if I just put this in my calculator, I end up with 0.809, and I can stop there because I know that I'm going to be rounding to 2 decimal places. And for the upper value using my calculator, I can stop there. So, and then my final answer rounded would be 0.81 and 0.89. So those are the 95% of my values. Sample values will lie between 81% and 89%. Now, just a quick note is if you don't have the type of calculator where you can enter this whole expression and avoid any sort of rounding, I just recommend always being on the safe side and using, at least 6 decimal places. So if I had to do that, okay, so here's how I do it. Would do it if I was rounding. I would just use 6 decimal places just to be on the safe side. Which rounding in my final step would once again give me 0.81 and 0.89. So 95% of the sample proportions will fall in this range. Okay, so would it be unusual to get a sample with 285 Democrats? So remember that 263.5 was NP, and that's sort of our expected value. I mean, if there's 85% Democrat and you have 310 in your sample, you sort of expect 263.5 of them to be Democrat. So is 285 Democrats, is that like especially or unusually high? So in other words, is that more than 2 standard deviations above the mean? You could find the z-score. That's one way to do it. And you can note that 285 over 310 is about 92%. So if you think about it, that is more than 2 standard deviations above our mean. So our mean, remember, was about 85%, and the standard deviation of the sampling distribution is about 2%. So this is kind of sloppy, but that means 89% we're looking at, we are about 2 standard deviations above the mean. So this is definitely more than 2 standard deviations above the mean. In the sampling distribution of p hat. So that implies, yes, this is unusually high. The last question I want to take a look at is F. What is the probability that a sample proportion is less than or equal to 80% Democrat? So in other words, what is the probability that I'm going to get a sample of, randomly select a sample of 310 voters where 80% or fewer are Democrat, when the mean is 85% in the population. So the probability of getting a sample that is less than or equal to 80% Democrat is equal to the probability of getting a z-score that is, and so I'm going to convert this guy to its z-score. We have 0.80 minus the population mean here over the standard deviation for the sampling distribution. Okay, and so remember, just to be clear, this guy is, the z-score in this case is going to be our sample proportion minus the mean of the sampling distribution over the standard deviation of the sampling distribution. So I just want to make that clear. And normally, like I said before, I would just pop this into my calculator and just avoid any sort of rounding, because rounding errors can really add up. If you can't do that, just use, just be conservative and use a lot of decimal places. For example, I'll, if I wasn't doing it with my calculator, I would use these, 6 decimal places that we had before. And this gives me, so since this is a z-score, I know I only have to go out to 2 decimal places. I'm just going to stop there. And how am I going to figure out this probability? Well, remember, it's a normal distribution. So here I am back in the normal table, and in this case, I am just going to look for a z-score of negative 2.47. That takes me to this number, so that is the area to the left of negative 2.47. So the area from the table was 0.0068, and that is my final answer. So there is about a 0.68%, less than 1% chance that of getting a sample. Proportion less than or equal to 80%. Last question I want to propose informally is just to ask you, what do you think would happen if I, say, quadrupled the sample size? So we were sampling 1,240 voters each time. So in that case, if you increase the sample size, what's going to happen is there will be less variation in the sample proportions because you have more accuracy, right? You have more information in each sample. So what's going to happen is that our standard deviation is going to get smaller. So that's an important thing to notice when you're working with sampling distributions, is that when you increase the sample size, the variation among the sample proportions will decrease, and then in particular this number is going to get smaller.